Okay, so my dear class 10 students, we'll continue with the part 7 for chapter 4, that is carbon and its compound science. So today we are going to discuss about the last topic for this chapter, that is saponification. Saponification. Clear? So this is the topic, saponification. Now, this saponification is very important. Okay, this process is very important because through this process we are going to study how soap is manufactured. Clear? How soap is prepared. How soap work. Okay, soap and detergent, how they work. So students, how do we get this soap? Clear? How do we get this saponification? Now let's study this process in detail. Now, do you remember I have discussed about ester yesterday, right? Ester. In the last class we have discussed about ester. And ester, this is nothing but it is a fruit smelling. It has a fruit smelling agent, right? And this we get in fruits. So whenever we react an ester, okay, whenever we react an ester, with a base. Whenever we react an ester with a base, okay, students, we will get a product as well as we'll get an alcohol product. Clear? We'll get sodium ethanoate. Clear? So let's see. This ester, as we have already studied, students, we get it. This is the formula for ester, right? Now base. When you say in chapter 2 we have studied about acid, base and salt. So base, we are using sodium hydroxide. Clear? So this is ester and this is a base. Now, so this is sodium ethanoate, right? CH3COO and A. Clear? So students, see, let's take out the sodium ethanoate from here, okay? See. So what is left? We are left with C2H5OH. C2H5OH. Clear? So students, from here we get this sodium ethanoate, and then this is the product of alcohol. And this process together is known as saponification. When we react an ester with a base, then we get sodium ethanoate along with alcohol product, that is ethanol. But students, out of the two products that we get from here, from this reaction, we are more focused on this sodium ethanoate, okay? Because this product we use for the preparation of soap. Clear? This product we use in the preparation of soap. And this is how we get this reaction, okay? So you have to, first you write in general terms, okay, so that you understand better. In general terms, you write ester and base would give you sodium ethanoate and ethanol. And after that, you apply the chemical formula and then write these products. Clear? But you have to keep in mind that we are focusing more on this product. Clear? Okay. So now let's study about the difference between the soap and detergent. Okay, soap and detergent. Okay, so students, just now on reacting ester with a base, we got this product, right? We got this product, and I told you that this product is where we use for the production or preparation of soap. So soap will define as, it is defined as sodium salt of acid. Clear? Sodium right? Sodium salt of acid. It is defined as the sodium salt of acids. Clear? Now students, why I said like sodium salt of acid? Now let's focus on the product that we got while reacting ester and base. The product that we got was sodium ethanoate, right? And I told you that this sodium ethanoate, we use it for the preparation of soap. And this was sodium ethanoate, right? Now when we look at this formula, we have this sodium, right? And then we have an acid. COOH was also there as a functional group in this compound, right? So we'll say that soap, the definition, it is defined as the sodium salt of acid, okay? Sodium salt of acid. Now, soap, it does not work well with hard water. The second important point is it does not work well with hard water. Now why I'm saying that it does not work well with hard water, because hard water means in water you will see some ions present, right? Often you say that this water is not good because it has a smell of irons. Do you remember that? Why? Because we have irons such as calcium and magnesium present in the water. If these irons are present in water, okay, because of the presence of this iron, it makes water hard. Clear? Now there might be a question in exam, why some water are hard? Because of the presence of ions such as calcium and magnesium. Now when in a water, okay, when in a hard water, if we put a soap, okay, if we put any soap, do you think like it will dissolve well? Do you think this will work well or not? No, it will not work well. Clear? So two important points that you can write under the soap is, first you write about a definition that it is defined as the sodium salt of acid, okay? And second, you write that it does not work well with hard water, because it does not dissolve well, right? So you can try, okay? In water, what you can do is you can just put the soap and you see whether it will work well, whether it will dissolve well or not, okay? So if it does not dissolve well, then that shows that there is irons present in water such as calcium and magnesium. So that was about the soap. Now let's compare this soap with detergent. Now students, about detergent, okay, it is a sodium salt of sulfonic acid. Sulfonic acids. Clear? You keep this in mind. Detergent, it is defined as a sodium salt of sulfonic acid. Now this sodium can also be replaced by potassium, okay? Potassium, because sodium and potassium, they are the hardest metal, right? They are the most reactive metal. Now it is sodium salt of fatty acid. Now when I say fatty acid, these acids are the oil, okay, the oil that we get from the vegetable, okay, vegetable oil, or from pork, you know, like pork fats and all, those are fatty acid. So the main difference between them is soap, it is a sodium salt of fatty acids, and here detergent, it is a sodium salt of sulfonic acid. Now what did I say about this soap with water? I said that it does not work well, okay? It does not work well with hard water. But what about detergent? Detergent is, it works well with hard water. And that you know, right? If in in a bucket of water, what if you put some detergent? It will dissolve, right? You will see bubbles coming out. So we say that it works well with hard water. Unlike soap, it does not. It does not work well. Clear? Now, this is the basic 2 points of difference between the soap and detergent, okay? So just you have to keep in mind that soap, it is made up of fatty acids, okay? Oil and vegetable oil, pork fats, so those are fatty acids. Now detergent, sulfonic acid, SO3, clear? And second point, it works well with hard water. It does not work well with hard water. Clear? Now, why it does not work well with hard water, and how does this soap work inside the water? Let's see that, okay? So, the next topic would be cleansing action of soap. Cleansing action of soap. Okay, so student, now let's discuss like the cleansing action of soap, and in other words, how does this soap work inside the water? Clear? Now, the structure of soap molecule will be, it is like this, okay? So this CH3COO-NA is sodium ethanoate, right? And sodium ethanoate is where we use for the preparation of soap. Now, this part we consider as a long chain hydrocarbon, okay? This part we consider as a long chain hydrocarbon. So this long chain hydrocarbon, we represent it with like this, okay? So this I'm showing you the structure of soap. Okay, so this will be a long chain hydrocarbon, long chain hydrocarbon. Okay, so it will comprise, why I'm saying it's long chain, because soap, it will comprise of 17 carbon, hydrogen 35. Clear? So it will be very long. It will be very long. And here, so let's say this is the tail part, okay? The tail part hydrocarbon, the tail part will be a hydrocarbon, and the head would be the iron part. See, this one will be iron, right? So this one. So this is the head part, okay? Head and a tail. So soap, though we don't see it because it's already joined, everything is in the form of a cluster. But now if we just see a single soap in a microscope, then the structure will look like this, okay? The structure, it will have a tail part as well as it will have the head part. So the tail part is the long chain hydrocarbon and the head part is the iron. Now, what will happen, okay, if we put this soap inside the water? Now, inside the water, let's say that we have this dirt, okay? Let's say this is the dirt or grease or dust particle. I'm just showing you like this, okay? We have the dirt particles in the water. So let's say this is a bucket of water, clear? Here we have water. And inside the water, we have this dirt, okay? Now, one thing, students, you have to keep in mind is that now the tail part, the hydrocarbon, okay? The hydrocarbon, we have this tail part, hydrocarbon would be we'll call it as hydrophobic. Hydrophobic means they hate water. They don't like water, okay? They don't like water. And this one, the head part where we have the iron, we'll say that they are hydrophilic. Hydrophilic. Hydrophilic, okay? ILIC. Hydrophilic is the head part. This means water loving. Water loving. So soap, how do they look like? They look like this, okay? They have a head and they have a tail. And head means they love water, and the tail means they hate water. That's why I'm saying it's hydrophobic, okay? Phobic. So it is water hating. And the head part, they really like water, okay? So what happens if we put a soap inside the water? What will happen? So the shape of the soap, it looks like this, right? So let's see what will happen if we put this one inside the water. So this is already a water here, and then inside the water we have this dirt, okay? Dirt. So whenever we put this soap inside the water, this part, the tail part, they don't like water, right? So they go and okay, so this is how it looks like, okay? Whenever we put this soap inside the water, the tail part, instead of like, the tail part, they will join with the dirt, okay? They will join with the dirt since they are water hating, okay? They would not face their head towards the water, but they will face their head towards the dirt. So we'll have many soap molecules, right? We'll have many soap molecules. So all together, what they will do is they'll form a clusters. See, so inside the water, this is how it will look like, okay? The head part, since water is a polar, right? The head part, the iron part, they will face towards the water, and the tail part, they will face towards the dirt. And together, they will form a cluster, okay? They will form a cluster, which is also known as micelles. Micelles. Clear? Micelles means the soap molecules, what is happening inside here? They are forming a cluster, right? So this is how the cleansing action of soap takes place. Clear? This is how the cleansing action of soap takes place. Now the long chain hydrocarbon part, the water hating part, what they do is they form a join, okay? They will be joined with this dirt particle, and when, you know, like in washing machine, okay? Whenever the machine starts, this dirt will be taken away by the long chain hydrocarbon. This dirt will be taken away by this one, okay? By this tail. So this is how the cleansing action of soap takes place. So under the cleansing action of soap, what you have to remember is the structure of the soap, okay? The structure of the soap. The other thing what you have to remember is you have to show how it works, okay? So you have to show the dirt as well as the head part and the iron part. And the last thing, you have to write the definition about this micelles as well. Micelles is nothing but this soap, they form a cluster, right? The soap molecule, they form a cluster, and that is also known as micelles. So students, we have covered all the topics like under this chapter. So whatever we have discussed, okay, from part 1, you go through that. And chemistry, for chemistry, we have just one chapter left, that is chapter 5, periodic classification of element, that we will do in the next class. So the first 4 chapters we have completed. Okay, thank you so much, students.